Here we're going to be working on a mail-in. This is an expedited service repair, so customer wants it done fast. It's an iPad mini 2 board, as the customer stated here. And customer also mailed in what looks like a charging flex cable. So he mailed in the iPad mini motherboard and a charging flex cable. That's it. And if we read what the customer said here, referral source, prior customer, issue description, lifted pad for the charge port. Let's take a look and see what's going on. So customer attempted to replace the charging port, but he knows what's going on under this charging port. He's telling us that there's a missing pad. What we have to do right now is we have to remove this charging flex. We'll inspect the pads under it. If there's a lifted pad, a missing pad, we'll attempt to fix it and solder a new charging flex on this board. So that's the reason why the customer mailed in the charging flex cable. The back here says iPad mini 4 charging flex. I'm very positive that iPad mini 2 and iPad mini 4 charging flex cables are different, but I'll have to check and see. Maybe I'm wrong. For now, we have to desolder the flex cable that the customer soldered onto the board, which is this one right here. Based on first impression, I do not think that this is aligned. This one looks like it's aligned, but this one needs to go down a bit. Okay, I'm currently at 375 degrees. And the reason I did not add low melt solder, or I'm not going higher on temperature, is because there was a prior repair attempt on this. And leaded solder will melt at a lower temperature than unleaded, so we do not need to have a lot of heat, and we do not need low melt solder. And it looks like the customer already attempted to fix the broken pad. Look at the wire here. Rest of the pads, they look good. No problem. This tablet is for Brandon. He's a prior customer, and we're gonna take care of him. We take care of everybody, but when a customer is a return customer, we just give him that extra love. When a customer appreciates what you do, we have to return back that appreciation and add on top of it. Okay, I do not know what's going on here. I have no idea what's going on here. Let me get rid of the glare. Let's clean everything up. I'm gonna take a look at the board diagram for iPad mini 2. So right now I want to look at 1, 2, 3, 4. I want to look at pad number 4. What does pad number 4 do? If it's ground, then we do not need to worry about it. And pad number 4 connects right here. So it is important. Pad number 4 is important. Right now the customer scratched a lot of the mask on the board here, so I cannot make out what's going on here. Like, you see this? I can see that this should connect with this. This pad here should connect with this. I can scratch it and I can connect the wire, but in here I cannot tell what's going on. We cannot connect the wire from here to here because we're going to be shorting the circuit. This is ground, and if we test just to verify, meter in continuity mode, and let's see, black probe on ground, and this is ground, whereas this is not ground. So the wire from here to here was wrong to begin with, because you are shorting whatever this does to ground. So how are we going to do it? How are we going to do this? We know that this pad connects with this red dot here, so we can run the wire from here to here, but we have to make sure that the wire is not going to touch the scratched area on the board. It's a little bit tricky. We're going to have to use enameled wire and probably solder mask, so we can mask that board and not expose ground. Let's start by masking the board and hiding that scratched area on the board, because we cannot run jumper wire with this exposed like that. Okay, very good. Now we're gonna expose the mask to UV light so that it can harden. And once the mask is hard, we can run the jumper wire. Okay, so let's see. And this is hard like a rock. Very good. So let's go ahead and solder a wire. We're gonna do it from here and run it over to here. We're gonna be using enameled wire, and enameled wire, in simple terms, it's more like an insulated wire. It has a special coat over it. Once exposed to heat from the soldering iron, the coat will melt from the wire, exposing the copper inside. So it's safer to use enameled in this case, because we do not want copper to touch this ground layer on the board, even though we have it masked. Just to be on the safe side, we're going to be using enameled wire. So we're going to run it from this point right here, and I'm going to add a little bit of flux. And let's add one tiny blob of solder. I think that's good. And all we have to do is cut that wire. Okay. So let's apply solder mask on several areas of this wire so we can hold it down in place. Okay, so I'm going to hold it in place while I expose it to UV light. So that's enough UV light. And that wire is solid. All we need to do is tin the tip of the wire. Okay, we can tell the wire is not tinned yet. We need to burn off that coat on the wire. And now it's nice and shiny. So now it's done. The pad from the flex cable will now stick onto that wire. What I did is I just grabbed an iPad Mini 2 charging flex cable, and it's different than the one the customer sent. iPad Mini 2 and 3, they share the same flex cable. iPad Mini 4 and 5, they share the same flex cable. So the one the customer sent is not the same. Even though it may work, but it's not the same. Yeah, so the one the customer sent, which is this one here, it's slightly longer in length, and it's different. So we're gonna be using ours, which is the iPad Mini 2 3 flex cable. What I'm going to do is prep the pads, pre-apply solder onto the pads. And we can do it in two ways. We can put the flex cable and then solder over the flex cable, or we can pre-apply solder onto the pads. And then we can press the pads over the solder, and solder will go out through the holes of the flex cable. I'll show you what I mean. Okay, so we applied flux. And let's pre-apply solder onto those pads. Circular motion, and I mentioned that technique in one of the videos. Where did I learn this circular technique from? Nowhere. Just trial and error. So whatever I discover, I share with you. Okay, everything is nice. We have solder on all the pads. We covered all the pads. Everything is good. Just want to hold it in place. Okay. Now I'm gonna press the pads one by one. I just want to make sure every single pad is making a good connection with the pad on the board. So we're gonna add flux. Flux is your best friend. You can never have enough. So we're gonna press on every individual pad. Make sure it's soldering properly to the pad under it. And then we'll run over them all at once to make everything look nice and pretty. So pin number 4 is right here. Pin number 4 is right here. Just one last run. A little bit of flux. I mean, it looks like it's a lot of flux under the microscope, but it's honestly a drop of flux. We are looking at this image under a microscope, so it looks like it's a lot. Just go in a circular motion like this. And look at how nice those joints are. Perfect. Better than factory. Better than factory. Okay, clean up and we're gonna test. We'll test using the TriStar tester. It will give us a good idea if the flex cable is making a good connection or not. If we get a pass, the job is done. If we get a fail, we have to do it again. I hope we're not gonna do it again, because I have 6 million things to do. Okay, so we're going to use our TriStar tester to test. It shows connected, which is good. That's a good sign. Let me go under the microscope so you can see what I'm seeing. First step, the TriStar tester is showing connected, which means that the flex cable is stuck into the motherboard. It's making a good connection. But we still want to test it. I'm going to press the button. And it's being tested right now. And it's a pass. It's a pass. Job is done. Job is done. Okay, that's it. We're gonna invoice the customer, mail it back to him, and thank you, Brandon, for being a return customer. I hope you enjoyed the video. Leave a comment if you have any questions, and we'll do something else in the next video.